Today we will discuss about IP addressing. IP addressing is a logical addressing. It works on the network layer, that is the third layer of the OSI model. It is distinguished into two parts, that is IPv4 and IPv6. IPv4 consists of 32-bit addressing. IPv6 has 128-bit addressing. 32-bit of IPv4 is represented as follows: a series of ones and zeros. These 32 bits are divided into 4 octets. This notation is known as dotted decimal notations. Total it has 4 octets. IPv6 is a 128-bit address which is divided into 16 bits. It has 8 sets of 16-bit address. Further, these 16 bits are converted into 4 digits of hexadecimal numbers for simple representation. These are separated by colons. This notation is known as colon hex notation. A simple example of IPv6 is shown on the screen. Now we will see the binary to decimal conversion for your IPv4. We just take an example for the first octet, which has total 8 bit. Each bit can be represented by a 0 or a 1. So in total we can have 2 raised to 8, that is 256 combination, starting from 0 till 255. So total range of IP address will be 0.0.0.0 till 255.255.255.255. Now this total addressing scheme is divided into 5 classes for IPv4. Class A, Class B, Class C, Class D and Class E, out of which Class A, B and C are dedicated for LAN and WAN. Class D is for multicasting. Class E is dedicated for research and development work. Now we use a priority bit to identify the addresses from each class. Priority bit is the leftmost bit of the first octet in all the addresses. So for class A, priority bit is considered as 0. For class B, priority bit is considered as 10. For class C, priority bit is considered as 110. For class D, the priority bit is considered as 1110, and for class E, priority bit is considered as 1111. Now we will calculate the range of each of the class. So for class A, the range can be given by the following calculations. The first bit of the octet should be reserved for the priority bit, which is 0 in case of class A. So we have given 0 for the first bit. We can vary the rest of the bit from 0 till 1. So we can have the first address as 0 and the last address as 127. So the range of class A will be from 0.0.0.0 till 127.255.255.255. The range of class B can be calculated as follows. The first two priority bits for class B is 1 and 0. They are given as 1, 0 and XXXXX. So the first 2 bit will be constant and the rest 6 bits can be starting from 0 till 1. So we have the range of class B from 128.0.0.0 till 191.255.255.255. Same way we can calculate the range for class C. The first 3 bits of the octet are for priority bit. They are 110 for class C. So we will keep that 3 bits constant and vary the rest of the bit. So we are starting from 192 till 223. So the range comes from 192.0.0.0 till 223.255.255.255 for class C. So range for the class D can be calculated as follows. The first 4 bit for class D will be 1110, that are the priority bits. So the starting number will be 224 and the ending number will be 239. So the range for the class D will start from 224.0.0.0 till 239.255.255.255. Last but not the least, range for class E. The priority bits for class E are 1111. So starting number will be 240 and the ending number will be 255. So total range for class E will be given from 240.0.0.0 till 255.255.255.255. The IP address is divided into two parts, that is network portion and the host portion. For class A, B and C, the network and the host portion are written as follows, which you can see. Network bits are 8 in class A, there are 16 bits for network portion in class B and 24 bits for class C. So now we will calculate the numbers of network and the host in class A. The octet format for class A is as follows. First 8 bits are the network bit, the rest 24 bits are the host bit. So number of networks can be calculated as 2 raised to 8 minus 1 for the priority bit used for class A, that is 2 raised to, so that it leaves us with 228 minus 2 for the address, the first address 0 dot and the last address 127 dot. So total networks we get is 126 in class A, and the number of hosts are given by 2 raised to 24 minus 2. Minus 2 is for the network IDs, the first and the last 0 and 127. So total it gives us 16777,214 hosts per network in class A. Same way we can calculate the numbers of network and the host in class B. The total number of network bits are 16 and total number of host bits are also 16. So over here number of networks is given by 2 raised to 16 minus 4. Minus 2 represents the priority bit, number of priority bits used for class B. So in total we get 16384 networks. And the number of hosts over here are given by 2 raised to 16 minus 2, that minus 2 represents for the network and the host ID. So in total we get 65534 hosts per network in class B. So similarly in class C we have 24 network bits and 8 host bits. So we get 2097152 networks and only 254 hosts for per network. The network addresses is represented with all the bits as 0 in the host position of the address. The broadcast address is represented with all the bits as 1 in the host portion of the address. The valid IP addresses lies between the network address and the broadcast address. The only valid IP addresses are assigned to the host or the clients.